So today we're building on the idea of a titration with what's called a back titration. And I'll get into what that means a little bit in a few minutes. But what we're looking at today is we're going to be analyzing an antacid. So we have some crushed powder of an antacid in here that we've already measured out, and that is 0.31 grams. And so since we care about the mass of the antacid and how much base is in the antacid, we are going to do a back titration related to that. So because most antacids create a buffer system, and in this case we make a carbonate buffer system, when we add acid to it, we will necessarily create a buffer in our solution, and that will cause problems. So here we have about, say, 49.9 milliliters of hydrochloric acid. And we're going to add this to our antacid. And as you guys can hopefully see, this mixture has become cloudy, but it also bubbled a little bit. And that bubbling is the carbonate buffer system that we created. When you add an acid to a carbonate, you will eventually form carbon dioxide, which is what causes it to bubble. The cloudiness isn't too much of a concern. That's usually the other binders and other inactive agents that we don't really care about. But to get rid of this buffer system, buffers will resist changes in pH and will consume acid or base added to them before we get to our titration. So to kind of overcome this, we have added lots of acid compared to the amount of base, which is why we added that much HCl. But we're then also going to boil this flask to get as much of the CO2 out of that solution before we do our titration. So because what we cared about was the base in the antacid, and we added a lot of excess acid to it, we will then need to back titrate with base back to our equivalence point because we have overshot it with acid at this point. So we do have sodium hydroxide in this burette, and we will be back titrating to our endpoint after this boils. So starting to boil, we should be able to pull that off in a minute. While we wait for that, our starting volume of NaOH is about 7.18. And again, make sure whenever you record these volumes, you record them to the correct number of decimal places based off of the increments of that glassware. So with our 50 milliliter graduated cylinder, it's divided into 1 milliliter increments, so you can estimate that next decimal place of 0.1 milliliters, which is why we have one decimal point here. For the burette, it's divided into 0.1 milliliter increments. We can estimate our second decimal place here. And so once we do our titration, we will have that. At this point, I'm going to pause the video for a few minutes just to let this finish boiling, and we'll come back when this is ready to begin. So now that we've boiled and cooled our solution, we should have all of our carbonate buffer system out, and we can begin our titration. Everything left at this point should just be the excess HCl from what we added. So, one of the most important parts of our titration is our indicator. Today we'll be using phenolphthalein. Very hard to say, even harder to spell. A couple of drops of our phenolphthalein indicator into our solution, and what you can see at this point is nothing has changed, which makes sense for phenolphthalein. In acidic conditions it is clear, in basic conditions it will be a very vibrant pink. So I still have my NaOH titrant in my burette. I can move the waste beaker and we can go ahead and begin our titration. Spin this around so that I can swirl with my right hand and titrate with my left hand. Hopefully what you guys will be able to see in the video is as the HCl hits the analyte solution in our flask, there's a slight flash of pink. And it's very, very brief right now, but what we'll see is that pink will last for longer and longer as we approach our endpoint, and then it'll stay. There we go. That pink is now staying for longer and longer, which is good. But it still disappears when we swirl it, meaning we're not quite at our endpoint yet. At this point, if you were doing the titration, you would definitely want to be going drop by drop, and maybe even stopping every now and then just to make sure you can completely swirl it to get it to go away. At this point, since we're approaching the endpoint, a single drop, half a drop can be all we need to change it to the pink we want. See, that was probably 2.5 drops. And we're at our bright pink. Normally, this actually looks maybe a little too pink, but that's all right. It's only a drop or two over. If you weren't sure if it was pale enough, then you could always record this volume, add a drop. If it gets a little more pink, then go ahead and use your new volume. If it doesn't get more pink, then you were already over your endpoint. You would just use the volume you had. So if I go ahead and record this volume, I'm at, let's see, 16.98, and at this point we should have all of our measured values to be able to do our calculation. If you were doing multiple trials, so if you were in class doing this, you could then use your current volume to start trial number 2 and 3 and so on until you're done. Since I'm only going to do one trial, I'm going to set all of this off to the side, put my waste beaker back under it just in case any drips out, and go ahead and start doing the calculations.